So, thanks for coming. This talk has like a funny history a bit. So like a couple of years ago, I worked something with JUnit 5 and I needed something for Kotlin, so I was using Reflection for a bit. And I thought, hey, this is very interesting. Let me dig into the API and show you what I had to do there. And I submitted this talk a couple of conferences, and they were always rejected. No one wanted this talk. I completely forgot about it. I gave up on it. And then last year, droidcon Amman in Jordan happened the first time. And they needed a second talk, and I only had one prepared. I said, oh wait, I have this old one I found here in Session Nice that I always wanted to do. So I prepared it, I came there. It was their first conference, things went a bit sideways. The talk was canceled, it never happened. I said, okay, but I have a talk now that I try again for conferences. So there was a conference in Prague this year, a couple of weeks ago, or 2-3 months ago. Yeah, I came there with my laptop and the computer froze during, this is live coding, there's no slides. The computer froze maximum every 5 minutes. I had to completely reboot it, the whole presentation. So live coding is a bit bad. I hope this time goes a bit better. This is a loaner laptop. I bought a different one. And yes, I put stickers already on the loaner. Don't tell my boss. And I have the broken laptop as my backup, so let's see how things work. I don't have a good track record live coding. I did it once here at droidcon a couple of years ago. I think I had like a blackout, didn't know how to type the pipe anymore, and it wasn't on the keyboard because it was a German keyboard. And another time, the E keyboard fell off in the middle of the presentation, so let's see. But I think worse than Prague, it cannot be happen, but yeah. I'll try the same, no slides, all code, and I hope you enjoyed it. Cool. I'm Danny, I work for SoundCloud. Our headquarters here in Berlin, streaming company, biggest audio catalog in the world. You found all your mainstream music there if you like it, but actually it's more important for the next artist, the next hip-hop artist, the next electronic artist will be there. We have a cool crew, they're sitting here, some developers from SoundCloud. Make some noise. Cool. So let's talk about Kotlin Reflection. And I have to warn you, this is from the official documentation of Oracle. This is a relatively advanced feature and should only be used by developers who have a strong grasp of the fundamentals of the language. So please be warned. You have been warned. Because it can enable applications to perform operations which would otherwise be impossible. So this is about Kotlin Reflection. If you've been in the previous presentation in this room, this is like baby stuff compared to like Kotlin symbol processing, but still I hope it will be interesting for the ones who never did much reflection. So what is reflection? According to Wikipedia, in computer science, reflective programming or reflection is the ability of a process to examine, introspect, and modify its own structure and behavior. Very straightforward, sounds interesting. According to Kotlin Lang, it's a set of languages and library features that allows you to introspect the structure of your program at runtime. Functions and properties are first-class citizens in Kotlin, and so is the ability to introspect them. For example, to learn the type of a property or function at runtime. Very straightforward. And actually, it's very essential for using functional or reactive style. So even if you don't notice, it's different from Java, where reflection was this black art. You're actually using reflection all the time when we're doing reflective programming and reactive programming, so we'll see that. But let's start with some code. So let's assume I have like a function. I have a function called isOdd somewhere here. So let's assign it to something. As I said, it's not my computer. If I do typing mistakes, it's a different keyboard I'm used to. But at least it hopefully will last this presentation. So we have isOdd. So isOdd takes an integer and returns a Boolean. So what's the type of this function, right? We could write it like this. It takes an int and returns a Boolean. We could also write it as, as this is a function that returns a Boolean. I can also write it as this is a k function that returns a Boolean. We just need a new name. We can also write it as a k function 1 that takes an int, returns a Boolean. So there are a lot of variations. So what's this presentation about? We'll dig into this. What can we do with it? And also like, maybe how does it work under the hood, right? It's called behind the mirror. So it's all Java bytecode, right? How does this whole shit work? So let's dig in. Oh, that's not what I wanted to do. Let's delete it all. Cool. So let's start with k class, which is the basic type, and you've all handled this. So we have a class called droidcon somewhere here. droidcon Berlin.class. That's a K class. You probably did it many times. What can you do with it? I mean, you can ask for its functions, for example. Its member functions, static functions. If you ever wondered what's the declared functions and functions with the same in Java, the difference? One is the one that is on this level and one that comes from the parent. We can do this. There's members, which is basically functions and properties. So all very straightforward. And you can do all these things. And now maybe you think, why not use Java reflection? Kotlin has some features that Java doesn't know about. Is this a companion class? Is this a sealed class? These are the things where actually you would probably need a K class, right? So how do we create a class and reflection? Similar to Java, we have new instance. We can do create instance, very straightforward. Actually try to run this. Cool, worked. But let's assume I need something more deeper. There are multiple constructors. You can ask it, hey, give me your constructors, and then we take the first one. Take the first one, and then we can call it. It failed. All of a sudden, I need an argument. Very interesting. Actually, droidcon Berlin leads a list of speakers. Now we're going back to constructors. It will complain about it. It's a default argument, but now we need it. So you can pass, and it's a var arg. And this is like one of the first things we said, oh, wait. Maybe be careful with reflection, right? You lose a lot of the safety that you have during compile time, which is one of the nice features of Kotlin. So first, then let's take the parameters. Then we can check the type of the parameters, for example. First type, which brings us to the next important thing called a K-type. So what's the difference between a type and a class? I looked it up. So a type can be an actually class with an optional type argument. So, example, the type of a string is the class string. They are the same. It can be the type parameter of some declaration, like list T, where T is a generic type. And it can be nullable, non-nullable. And this is where you probably, when you think about in your head, class and type, return type of a function could be a nullable string, for example. So, where do we handle this in Kotlin? It's very nice. Nowadays, it's actually very easy. You can ask type of, there it is. You get the K type of int, you can just use the type of. In the earlier version of Kotlin, this was not available. This was a really nice addition. But we also just saw the example where, let me just copy this over, we had it here. Maybe, for example, ask for the parameters type. Just take it here. We can also ask, when we, for example, instead of the constructors, we asked for the functions. Take the first one. We can ask for its return type. This is a typical thing where you actually would introspect a type at runtime. So very simple. There's not so much that you need to do here, but we come a bit back to when you need to look into types later. So for now, just be aware there is type. There's a way to go back to class. You can get to classifiers. A class is a classifier. So there is a way back and forth. But yeah, there's a way in one direction, obviously not in the other. Cool. Let's talk to K functions, because we just asked droidcon for its functions, right? Let's get more interesting. So we ask the functions of the class. Come on, stupid. Functions, cool. Let's also get the first one. So you know the American versus English keyboard thing, the big functions. But first, cool. Okay, so we have a function. How can you call a function? They have a call, very easy. So we can call the function, similar to the constructor, because the constructor is a function. But let's come back to the original, how I started this, with the K function, the K function 1. So let's look at this a bit more. So droidcon Berlin has a function called has started. Let's start this. Returns a Boolean. So what's the type of this? Let's also call it my fun. As we said earlier, this could be it's a method that we call on droidcon Berlin that returns a Boolean. Boolean out of Berlin. You could also do, and this was the quiz this morning, you can write the same thing actually like this, because you have to pass in the instance, if you want to call this, because it's the instance of droidcon. But it's also, It is the function, and let's start with this one. So it's a function that returns a Boolean. So let's dig into what is function. Function represents a functional type, such as a lambda, an anonymous function, or a function reference. So it's kind of the glue code between proper Kotlin functions, like reflective function types, and so a K function is a function. There. But also like the lambda is translated to something that is a function. This is why it's a marker interface function. It doesn't have anything, but something that the compiler is using. Let's go back here. So let's assume you have this, so if this lambda is a function and it's also a K function and the other way around, let's assume these are vars. Can we assign them to each other, right? I don't know, doing some, does it work? Because they're the same thing, right? They're pointing to the same thing. Doesn't work. Can I do it the other way around? No. There's actually a nice thing. There's a function called reflect. You can actually try to use. It will not always work. But we'll look later into how this thing works. But there is a way to create this reflective description. That's basically what a K function is. It describes not only what you want to call, like the lambda, but all the properties. Then we'll look later what this reflect does. For now, it's important that actually, why do you need a K function, not just a lambda? Maybe you want to know some properties of this. Is this an infix? Is this open? You can guess for its visibility and things like this. So you want to check, okay, someone gave me this function, right? How is it used? You can actually ask, it's a suspend function, which is very interesting when we talk about coroutines later. So this is K functions. Actually, there's one more thing that all of these are. This is also a thing called a K-callable, which brings us to K-callables. It's basically, K-callable is basically either functions or properties. This is where you can see it. So when we go to droidcon Berlin, it has also some properties. I think a date we had, yeah, there's a date here. So this is a property. When I assign this to something, my prop, this is by definition as a K-callable that takes a date. And that returns a date. Cool. There's also K-property and callable. What does it mean? There's a method called call that we saw earlier. So if you want to get this argument, you just call it K-callable. So just a super interface if you ever run around. Just think, that's the glue code between properties and functions. Not much use for us. Let's talk about K-properties because they are much more interesting. Let me just keep the time in mind here. Cool. So actually, let's do the same thing again. We do droidcon Berlin and date. And this is a property. That's defined for on purpose. That's K property of a date. So similar, you can call it, but you can also ask some things. Is this a late init, for example? You can actually check if a variable declared late init. This might be very useful. Is it declared const? So a lot of the things, when you think about how to introspect, maybe even do weird behaviors. So a property can check if itself, if it was late in it. Why using K property in general? There is you can pass on a getter, then you only get access to the thing, which is interesting. But thinking this a bit further, what we just said about, wait, I can check how things are used. And K property, I heard this term before. Yes, you've seen this. Delegated properties is something we use actually in Kotlin a lot. You might not be aware, but for example, by lazy is a property delegator. A couple of years ago, I think in Munich at a meetup, I talked about property delegates, but let me show some simple examples how we can use this. So let's assume we want to create a new awesome conference. Class new conference. Cool. We need speakers, so I need a list of speakers. That's a list of speakers. And instead of just finding one, wouldn't it be cool if I can do just steal all the speakers from droidcon Berlin? So this by says we want to use a property delegate. How do you implement one? Let's ask. We can create an extension function. So without modifying droidcon Berlin, we can implement this. So let's just do it. Oop. So, okay. So this we can just return the speakers from droidcon. So just extension function. It's basically an operator, get value. This is all a delegator is. And you get two things. This gives access to the surrounding class you're used in. And this one gives you the property that we just checked, and we can check, so, am I used in a late init? And then I can do one thing, otherwise maybe something else. Like a nice idea, right? Let's just go back for a minute. Example. So we can also implement it directly, of course, in the droidcon Berlin. It's the same thing, just side here. You can declare that you have a property, but it's a marker interface, read-only or read-write property. If you're a library developer, it makes more use just to declare that there's actually one here, but there's no need for it. That's why you can use the extension function. All you need to have is an operator here. And interesting is this one. So you get access to the surrounding class. So we can check how we initialize and who's using it. So let's think about some dirty use cases, what we can do with it. So let's assume we have a class, I know something. And this has some properties, well, I don't know, prop, let's make it short. And this is by, I prepared like a property delegate here that takes the default value 0. And then let's assume we have a unit test. Oops, just duplicate this. So this is unit test. And you do exactly the same thing. And let's just print line what's happening when we do something. Yeah, it's good. Dot prop. And doing the same here. Something test. Let's run this. Oop. Shift R. And it says here, property was not declared in a test. Property was declared in a test. So, I mean, it's not a proper test, but, and then I have two different values. This is what I was printing. So all the way using the same way. Internally, there's some magic that have different behaviors and how you are used. Let's look at this implementation. It's just a demo implementation. So I have this is usually how you implement it. Oop, don't want any. Oop. It's a provide delegate operator that just returns a read-write property in this case. And it just says like, hey, this reference I showed you about, the any, are you declared in a test? Okay, it's as simple as this. Does the name ends with test? Not very sophisticated. So we thought, is there a better way how we do this? So a colleague of mine helped me, an ex-colleague of mine, thank you, Aiden. So we use the Java reflection here, take the stack trace where we are currently in and looking for, are we in org JUnit test? Also a bit dirty, but yeah, we're actually checking, are we somewhere in the call stack in a unit test? And then do something different. So thinking of like halting problem and all like this, so different behavior depending on how you actually used what you can do with property delegates. Yeah, this is the method we saw. Just to inspire you a bit of like things you can do. But property delegate can be very, very nice and useful. I'll show you some more later. So let's just turn this. Cool. Let's talk about coroutines for a moment. Kotlin Reflection was there before coroutines. Coroutines and friends come. droidcon Berlin also has a suspend function. It's called start event. Need to run a coroutine. Cool. Let's do what we never should do, right? We do unblocking. Then working. So how would I do this with reflection? So let's do droidcon Berlin, let's get the start event method. This is now a function and I can just call it. So what would happen? No compiler error, right? Dangerous, ooh. I need two arguments. Oh yeah, I need definitely droidcon Berlin. But I still need a second argument. Still need a second argument. And what's this argument? I mean, let's just go here, say show Kotlin bytecode. Because you always have to understand that you're going back to the JVM world. And if we do start event, it has an argument, the continuation. If you ever looked at coroutines work under the hood, right? You need this continuation block because this is just the way they're implemented. So we can't just call this in reflection. There were slides here. So what we have to do is first check, is this a suspend function? And if so, then we do call suspend. And then this works out of the hood. So, of course, now we need a running block, so now the compiler helps us, and now this should work. So this is, you can see, using everything with reflection would be very tedious. You have to check basically all the time how does your functions work. But there's full support for coroutines here, which is important to have, obviously. Let's go to the interesting part, like how does it work together with Java Reflection, right? The Java Reflect package. So, because when you do Droid, if you get a class, you can also get the class from the Java Reflection package. So where is the difference? I mean, obviously I showed there are some properties that are Kotlin only, that you will not have that are Kotlin one. But how they work together, you can actually, you know that you can do this, and this, and this, and this. So you can work from both worlds all the time, other than for types and strings. When you look at how that works under the hood, there's a reflection getter create class you can play with. Just give it a Java class and it creates a K class of it. The other one, by the way, if you ever wonder how this works, this is basically just, there's a property in a K class that references the original reflection one. So this is simple. There's some interesting things when you think about how Kotlin and Java work together here. Kotlin is transferred to Java bytecode. So we have some interesting things that we can do with when we have a K class. So we can ask every K class for its Java primitive type and Java object type. What is it? A Kotlin int is translated to a Java int, right? How does this work? I mean, when you work in a reflective program, this might all of a sudden interesting because you lose this safety. When you look at the implementation of Java primitive type, it's super funny because it's basically just a when statement. Because there's nothing you can add here. These are the defined ones on the compiler. There's nothing more that can be there. So there's no magic in this one. And the Java object type, it's very similar. So very similar, no magic here. What is more interesting is I think we need a type for that. So when you have a type, you can ask for its erased type on JVM, which is super interesting. So what's type erasure? Maybe this exists independent of Java and Kotlin. You have a list of int in Java, doesn't matter if Kotlin or not. And runtime, we all know because the way generics are implemented, is a list of objects. So the type is actually erased. So there are these helper methods that help you to understand what you might get erased to. Never immediately used to, but this is a nice thing to have. Is there anything else we need to from the Java side? Probably not. Let's keep going and let's think ourselves. So how does it all work? So we take Kotlin code, we compile it, it's Java bytecode. And then all of a sudden, we can do reflective magic and we can, by the way, ask all the properties from the Kotlin world on Java bytecode that we haven't written in code. So to understand how this works, let's go to our class droidcon and look at it again on a bytecode level. So Kotlin bytecode, we're not looking at bytecode, we're just using the decompiled version. And let's do class droidcon. Yeah, droidcon. So there's all the things, there's the speakers, right, the date, there's some private properties that can look later. And you've probably seen this once, and maybe never ask yourself, what is this? So this is weird annotation. And the Kotlin compiler adds this annotation to all your classes. And when we look at it, so this looks like the name, this looks like the field, the type of the field. So there is some information about actually what is in this class. So let's try to understand, because there's MV, there's K, what is this? So how did you find out? How about we look into metadata.kt. It's actually very well documented, there's no magic here. So, K, kind, this is a class. Yes, droidcon was a class. So this is just tells the compiler what, the reflective API or the compiler what this is. We had metadata version, let's see, let's just go back what we had there, 1.9, this might be my Kotlin version, just an idea. What else did we have? XY48, let's see if we find XY here somewhere. PNXY. So it's basically a bitcode mask you can translate to see some info how this is compiled. I think this is the one that is different if I do it with the decompile, which is a Kotlin script file, or then at runtime. That's also interesting to have. The more interesting is this D1 and D2. So let's see what this is. D1. Metadata in a custom format. This format might be different or even absent. Fortunately, not very helpful. Let's look at the second one. In addition to data 1, so D1 is data 1, array of strings which occurs in metadata, so it's the strings that are in that thing, written in plain text so that they're already present and constant in the string pool. So it's for optimizations that they don't need to be created memory-wise. Okay, it gives us info, so all the strings are in there, so, but all the magic is in this D1. So what do we do now? We want to understand how this D1 works. So let's go back to the slides. How do we do this? Let's load this annotation. So let's do class dot get annotation, find annotation, I think it's called. Find annotation, I want a metadata class. So let's print this. Any idea what this will print? No, there is no annotation metadata. Maybe you got it where we did it wrong. This sits on the Java class, it doesn't sit on the Kotlin class. So what we need is to find the Java one and ask the Java world, can you give me the annotation metadata class? And let's print this. Ooh! And it says some values, even more values than we just saw with the compiler. Cool, so now we have something, let's write it into the umbrella. So this is, let's show annotation. And now at least we can access D1, data 1, and data 2. So we have these arrays, which is nice. Don't ask me where I have this from, but it is a nice tool you can use. So at some point there's a hint that D1 is protobuf data. And there's a JVM protobuf util tool we can use. So I'll tell you later where I found it. And there's read class data from, which takes two arrays. Oh, luckily we have two arrays. Annotation 1, data 1, annotation data 2. Cool, what does this return? Let's see. It's a pair of a thing called a JVM name resolver and a protobuf class, which is. So let's define them. I think this is the very first time I had to use destructing declaration. It's also part of one of the puzzles this morning. Let's call this protobuf. Come on. Cool. Now we have these two objects. Now I can ask this protobuf, let's see what it has. So this basically is getting closer to what we have at runtime with Reflection. This has a list of all the functions. So cool, let's go to all the functions that this thing has. What is function? Oop. What can I do here? There's a name. The problem is the name returns an int. Oh, now remember there was a second array that has all the strings, right? Maybe this is why we need now the thing called a name resolver. So let's take the name resolver. Here is no method pretty, but I'll show you in a second what it does. It just makes it a bit nicer for us. It wants an int. Oh, cool, I have an int. Name. And it wants some type. I think I probably also have the type. Cool. That's one. And maybe let's print this. Know all the warnings because of like the compiler tells us, oh, careful, 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 you're doing evil stuff here. So my droidcon has started and start event, two functions. And now I show you what the pretty method does. It just makes it a bit more readable for us, but there's no magic here. It literally just uses the thing under the hood. Cool. So this way we can walk to the functions, to the properties of everything. So we loaded the annotation and successfully translated to something that is like similar to the Kotlin Reflection API. And now you might wonder, how the hell did I find it? Remember the very first example I showed you when I said there was a function that was of type, I don't know, something that returns a Boolean. And then I did reflect. And I said, ignore this for now. Let's look into this. So this tried to take a lambda and make it return a k function out of it. So what it does, it tries to load the metadata annotation. If it has one, it takes a tool called JVM protobuf util, read function data from list, which is exactly what we just did. It loads some more metadata, and in the end, it creates a k function impl, which basically takes these descriptors. So it's recreate implementation of k function based on this metadata. So exactly what I just showed you, this is where I stole the stuff from. So if you want to understand more, super easy one. Cool. So this is how it works under the hood. This is what we just looked at. Yeah, this was just examples. Cool. Okay, what else can you do with reflection? One example that I like a lot, so especially when it comes to property delegates, you can a lot of things. So this is my friend Aiden wrote. Hi Aiden, all to Dubai. If you're an Android developer, and you probably are because we're at droidcon, you probably handle with safe state handles, but also view models, and it's all a bit messy when you have to check all these cases when it comes to recreation. So we created a delegate called savable mutable state of. So we have a mutable state, but it also takes the safe state handle into consideration. So this is the default argument, this is the safe state, and handled it all under the hood for you. You just have a property, a state, that does both for you. We can have a look at it, give you an implementation. Similar to what I showed you, there's a provide delegate. He built some key value names here. There's not much thing here. So it works both ways. It just reads from the safe state handle and saves to it. So property delegates are super powerful. We have a few in our code base. For example, by disposable, you can have, whenever you add something new to it, it disposes the previous one. I think in one thread we have it off a file, just assign a file to something, just release the previous one. So you can do nice things. As I said, you have full access to the class, the surrounding class, and full access to how the thing is declared. So there's a lot of powerful things you can do with it. Another thing I want to show that this was the origin of the whole presentation, how I first time had to play with reflection. So let me go to the project, because I'm a unit testing guy. And I had a case in our application like back in the time. So we just move this up. So we had something like this. So I want to have a parameter as test. This is standard JUnit. And the method of login method is Facebook, Google, or Apple, just an enum. And this works. I mean, it's enum source by Kotlin, by JUnit, and it calls this test 3 times for each variation of the enum. But my problem is I didn't have an enum. I had a sealed class, because one of them is Facebook, Google, Apple, but it's also a manual one that needed an email, for example. So, but I want to have something similar, because there was a lot of tests I wanted to do on a tracking level. I didn't care about the actually usage here. So what I wanted was this, pass in the login method, and so I created a sealed class data source. And we can look into this. And this had to do a lot of the things that I showed you. So we looked at the classifier and checked then for certain type things. And it had to use a mix of Java reflection, Kotlin reflection, because not everything back then was there. For example, I discovered this nice thing called get enum constants by class name. I think we have util open, let me see. Util Java. This is my version of it, but you actually find it online in the Kotlin language. Because in the beginning you couldn't do enum.value off in Kotlin. It just didn't work. You couldn't instantiate it generically in enum type. It works now. This is nice. But for a while it didn't work. So they literally put in all the Kotlin code one Java file that just does this translation for them. So these small things, you discover what's possible in Kotlin reflection and what not. But in the end, I did exactly this. All I wanted to have, okay, if it's a byte, give me 0, right? Boolean false. I need a throwable. I need an empty map. Like if it's an array, I need actually to create an array of this type. Like a lot of weird things. So this is how this all started. So let's go back to our, cool. So what can you not do with Kotlin reflections? So because a lot of things that you can do. I remember when I wanted to give this talk and told someone, a friend of mine at Google about it, he said, but what do you want to talk about? It's like 3 functions. And it's like this, right? There's K-class, there's K-type. I mean, we just discovered K-function maybe, but not much more. But I managed to make a talk out of it. But actually it's on purpose very limited compared to what Java offers. Because it tries to give you the must-have you need. So all the language features it supports, you need to be reflective, accessible, but not more. On purpose, there's no API, Kotlin API, to access private fields, for example. So if you want to do something like this, on droidcon Berlin. Come on. You need to write import for on, this one. Let's do it like let's do this infix, but for now we can do this. Dot set, I don't know, there was, I think, costs to value, I think the symbol, set it to 0, the droidcon is for free, and we can write it infix. So this one is not Kotlin Reflection. This is like a third-party library, because exactly this they don't want to give you. You have to go back to the Java version or these other third-party that under the hood use Java Reflection. It's still possible with Kotlin because it's just JVM. What other implementations we have? Let's talk about the elephant in the room. Yes, using reflection is slower than not using reflection. I mean, we all remember the times, right, that reflection was the bad animal that we're not talking about on Android. It's a long time ago, things improved. You can definitely use reflection, but of course, it doesn't make sense to write your code completely reflective. And the limitations are with all the things that are missing. Like you can't just generate random code with Reflection API from Kotlin. You have to go something that's more code generation based, as the previous talk, for example, showed. So Reflection is fine, but be careful. To sum it up, so we have performance overhead. You have very limited access to private members. It is very less type safety, so you're losing a lot of the things that Kotlin wants to give us. But there are some powerful tools you can build for testing especially, and for some nice use cases like the property delegates. So please play with it. There are some links. I will post them online. Some nice article. They're not much you find out there, but the API is very limited in the end. So just play with it. And with this, I say thank you.